matches, oil, gas, so many different things. But as a broad catch-all term, we're going to say fuel, okay? So we have oxygen and fuel. There's a third thing. Does anyone know what it is?
Paper? No.
Yes. Air. Well, air is, kind of falls in line with oxygen. Everyone rub your hands together like this.
It gets really hot. Oh, yes.
Faster. What are your hands right now?
Hot.
Okay? When I take this match and I rub it against the side of this box here, what's going to happen? It's going to catch. Why is it on fire right now?
Because you didn't light it.
Because I didn't light it. Because I didn't rub it with friction, creating heat. Okay?
He's just showing us.
Exactly right.
That's from the old days. Wow!
So, raise your hand if you know exactly what's going to happen when I put this balloon up against. A lot of you guys are saying pop. Raise your hand if you think it's going to pop.
I don't want to hear it pop.
Raise your hand if you think it is not going to pop. Okay, so raise your hand if you know exactly what happened.
It popped.
What? It popped. Does anyone know why it popped? So, as I put it up against the fire, it began to melt. And that melting
Makes it pop.
causes it to pop. That thin spot in the balloon, because the balloons are pulled so tight, there's a thin spot in it. The pressure of the balloon is going to take advantage of that and it's going to pop because it wants to release. Okay? Raise your hand if you think this balloon will pop. Raise your hand if you think it won't pop.
Later.
Raise your hand if you've noticed the difference between the two balloons.
Wait. No, it has water in it. That one has water in it, so
It has water in it, okay?
But if it doesn't, it's not going to fire. It's not going to fire. It's not.
Raise your hand if you know how water in a balloon will affect the outcome of the experiment.
Because of the water.
How?
Because the water, like, can maybe take down the water at the fire and because it has a weak spot.
Someone said something about a weak spot. What happened? What'd you say? That is correct. So, in our first balloon, the reason it popped was because the fire created a weak spot. However, in this balloon, it can't pop
because it has water in it.
because it has water in it. And the water absorbs the heat faster than the balloon can melt, right?
Draw face on. Oh no!
Oh,
Draw face on it. Can you make a smiley face? He's doing it.
You guys know what this substance is? You guys know what this is? Well, the black stuff. Yes.
Ashes.
Ashes, like carbon and other ashes from the candle, the smoke. Like when you light a candle and a lot of smoke comes off, it's like that. So I have two solutions here. If you look over here, it is solution A and solution B.
B. What's solution B?
It's different than solution A. So what I'm going to do is I'm going to take this dollar bill and I'm going to dip it into solution A.
Use the real dollar bill.
It's not a real.
You don't want me to use the real one. So what do you guys think will happen when I light this on fire?
It's gonna melt. It's gonna melt.
that burned pretty badly, didn't it? It's not entirely burnt, but I don't know of any vending machines that are going to take that, do you?
I don't think he's a scientist.
I'm dipping this one into solution B. Solution B is almost like solution A, but it's just slightly different. Does anyone know how it might be different?
It won't burn. It won't burn. It won't burn. It's burning. It'll catch on fire, but it won't burn. Oh, it's on fire.
So what happened? So can anyone guess how solution A and B might be different?
The A was like some sort of oil stuff, and B was like some water. And then
That's exactly right. Solution B had the, I'll go ahead and tell you what it is. It's rubbing alcohol. The rubbing alcohol was mixed with water, okay? And it did burn, but because rubbing alcohol burns at a lower temperature than water evaporates, it couldn't evaporate the water from the dollar bill.
Thank you.
Sorry. I should have just kept it flat. So I have,
Is it wet? You don't want that.
it is a little bit wet because it absorbed the water
because
molecules.
it was water.
Right. So I have here an empty tray
It looks like candles.
with candles melted to the center of it.
Oh, that's a
Well, I'll dip the water in it.
And I'm going to put water in the tray.
That's not. That's not fair.
And then I'm going to maybe color it blue.
Ooh, color it blue. Oh, you
So, I have a question. What happens to most things when they heat up? Do they get bigger or smaller?
Smaller.
They get bigger. Okay? So, if things get bigger when they heat up, what happens when they get smaller?
Burn. They blow up. They burn. Yeah, they blow up.
Or when things, if things get bigger when they heat up, what happens when they get cold?
They blow up. They get smaller.
They get smaller. The logical train of thoughts is that they get smaller. Okay? So, what happens if we were to take away, what if I were to light this on fire here,
It would get bigger.
and then cover it with this Erlenmeyer flask, cutting off its oxygen? What would happen to it?
I can see the fire. Wait a minute. Oh.
Huh?
The fire.
Why would the fire go out?
Because you're not putting water in it. Put the water into it. It doesn't have
Because it doesn't have oxygen, and without oxygen,
it can't maintain.
it can't burn. So it's expanding right now. It's expanding the gases in there, and it's pushing it out. What's going to happen when the fire goes out and it starts to cool off?
It's gonna get.
Whoa! No, there's the wheel in it.
What does it do? That's
So as the gas is cooled off, they wanted to pull something in, but because there was an airtight seal, what did they have to pull in? The water. That's exactly right.
When the fire burns out, water comes. When the fire comes out,
I want it.
let me try. When the fire comes out,
So raise your hand. Raise your hand if you know how a tornado is made. How's a tornado made? Do what? Why don't you help her out?
It's cold air and hot air.
Cold air and hot air. When cold air and hot air meet in the atmosphere, they don't really want to mix well. Okay? So when they hit each other, they just kind of swirl around each other and create what's scientifically known as a vortex. But what is commonly known as a tornado. And this tornado or vortex picks up all the different water vapor and debris and stuff as it swirls around, and it picks it up and creates a tornado. So what do you guys think will happen when I spin this around in a circle?
It will make some kind of tornado. The fire will get bigger. The fire will get bigger.
So if that won't do anything, why won't it do anything?
Because the water. Because of the water.
There's no water. What I put in there was actually flammable stuff to make it actually catch on fire a little better. How is this grate going to change things?
It's going to turn into a fire tornado.
Why will it turn into a fire tornado? Because the grate as it spins pulls in colder air, and that colder air mixes with the hot air around the flames, creating a vortex shape, and also feeding the fire just a little bit, making it just a little bit bigger.
And then when you stop it, it stops.
And when I stop it, it goes back down to its original size. How am I going to put this fire out, do you think?
If you shut it, there was no more oxygen.
What?
If you shut it, there's no more oxygen.
If I shut it, it'll cut off this oxygen. Exactly. So I have one more experiment for you guys.
Cut them in half. The water experience?
No, it's another fire one. So in this container is extremely flammable substance. Okay? It is very, very flammable. I'm going to put some of it in my hand right here. And then try to light it on fire. What do you guys think? Take over my hand. How many of you guys think I'll burn this?
It won't burn because it's covering the fire.
It goes out.
Why did it go out? What happened?
Because it's very flammable.
My hand's dry. The blue stuff you see is the food color.
It smothered the fire.
And why would it smother the
Smothered
fire?
it.
So we had heat from the match, and we had fuel, the flammable substance in my hand. What was missing in that scenario?
Oxygen.
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 What is he doing now?
So what if we get that flame to be forming? Understand if you know what's going to happen when we add a bunch of oxygen.
It's gonna go down. It's gonna burn. Hey, you can't do
just some of the substances in her.
That was amazing.
Teachers now. I hope you guys had fun and learned something. I would add everything I did, I've been trained to do down to a T. Down exactly what you do.
Did y'all have fun today?
Yes, ma'am.
Did you learn anything?
Yes.
Awesome.
Did you, buddy?
Yeah? Can you tell me one thing that you learned today?
Did you learn something at the magic show? What do you have to have to get the fire? What did he have to have? What about it?
I go see my Mimi. Can I go to my Mimi? I don't know.
Okay.
I gotta have her sign.
Hi.
Best thing of the year.
Thank you guys for coming. Did you have fun today? You did? Can you tell me one thing that you learned today?
Tell her about the fire. You just saw that. Tell her about the fire, Daddy.
We was in the kitchen all day, but I forgot that.
Did it freak you out?
That fire needs oxygen, so it can be a fire.
Yes, yes. Fire needs oxygen to survive. Good job, you guys.
Thank you for having us.
We're so glad that you guys came.
And I don't remember, yeah.
What do you play?
I think I was in the TV series and we deleted scene.
Hey, can I talk to you for a second? What's your name?
Zach.
Zach? Did you enjoy your time at the museum today? Can you tell me one thing that you learned today?
Science.
What about science?
Just all of science.
Fire?
What
Did
about
you?
fire?
Yeah. What is one specific thing that you learned about fire?
That you don't play with it.
Yes, that is a good one.
What's all that white stuff?
It's flammable substance.
I gotta get a video.
You can get it tomorrow, no biggie.
Do not do this.